Okay, let's try this again. For some reason, the ShowMe app keeps closing on me, keeps crashing. They were supposed to have fixed that with the last update. Obviously, I've never had a problem before until now. They might want to go back and recheck their fix. All right, so linear. Linear is both direct variation and indirect variation. Okay? So, that we have both. So on a graph, I'm going to put two graphs here. This is your direct, this is your indirect. Okay? And we'll use some color. Let's see. Direct. Direct variation just means this thing is going to go upward, and basically it can be stated when x increases, y is going to increase. And it's going to be a linear or straight line. Okay? It will cross both axes. Okay? It'll cross both of the axes. All right? For indirect, we're going to go down. And it doesn't matter if it's here, or I could have drawn it, let's see here, I could have drawn it down here. It does not really matter. So I'm just going to keep it up there just for room. Okay? This is x increases when y decreases. Now don't get that confused with the inverse, because the inverse is a curve, and yes, it does the same thing when x increases, y increases, but it's just the fact that both the linear and the inverse do have some effect like that. All right, if it's a straight line, it is a linear indirect variation. If it curves, it's an inverse variation. All right, so it also cross both. It'll go across both axes. All right. That being said, let's go to the next page. Hopefully this thing doesn't crash on me. Okay, this has probably got the most information. The parent function. Oh, let's get a different color. Let's try blue. I like blue. Parent function. Parent function for this, y equals x.
Christian Borieto, please come to the main office.
Okay, so there we have another announcement. Okay, let's see, positive function, y equals x. The equation, however, is, equation, y equals k of x. But k is a constant, just like in inverse, is a constant. All right. Now, you're actually going to use a form of this, but you're going to use what's called the slope-intercept form. And there is one of my classes, I was just missed it today. I probably told you it was a point-slope form. It's slope-intercept form. Make sure you go back and change that on this one. Okay? Slope-intercept. Slope-intercept. Yes, even I'm sitting here looking at my notes, and yes, I did it on there too. It is the slope-intercept form. All right? And that is y equals mx plus b. That's because m is my slope, and we use y2 minus y1 over x of 2 minus x of 1. And then we could say that's the difference of y, or delta y over delta x. Yes, those are Greek. The triangle is a Greek letter for delta, and that's just known as the difference of. When we're talking difference, we are talking subtraction. That is why you have the y2 minus y1 over x2 minus x1. Remember, those can come from a table. Always go to a table. Always go to a table. Okay? And the last thing about this is it is rise over run. All right? And might be something we need to talk about on that as well, because if it's a negative, then we'll go from there. Okay? The added feature on this equation of slope-intercept was the b. Okay? And I use it, I always students that the plus b means to balance the equation. Back when we were doing sequences, back in 6th, 7th, or 8th grade, you balance the equation by adding or subtracting a number on it. Well, that's balancing equation. So we balance it here. All right. B, though, is really called the y-intercept. Hence the term slope-intercept form. Intercept. Okay? And what that means is where the line crosses the y-axis. And it is going to have the coordinate point of 0 and whatever b is. Because remember, if x is 0 and we put it back into here, then this whole feature disappears and then y equals b. Okay? So when x is 0, y equals b. All right? See if that helps you with your understanding of linear. All right? And it works both positive and negative slope. There are two other slopes that really don't fall into a linear per se, but I at least teach them with it. And two other slopes are the zero slope, which is a constant, and you'll usually see it as y equals k. Okay, there is no x. You know, if we were to graph that, we could probably say, let's just say y equals 3. If I do that, then basically what I have is I have a line that goes through 3. Okay, there's no slope to it, zero slope. The other one is called undefined. Undefined slope, and basically it is a vertical line. Okay, and you're going to have x equals, I don't know, let's use 3 again. Okay, if x equals 3, then it's a constant. Okay, and if it's a constant, it means I have no y-intercept. If I have no y-intercept, can I even use the formula back there for slope, the y2 minus y1 over x of 2 minus x of 1? Right? It doesn't cross the y-axis, but we do have y-coordinates, because think about it. I could pick 2 points here. Let me put 2 points on here. Say one here and one here, and let's just say my first coordinate down here is 3, 1, and this one is 3, 3. That should be a 3. Well, let's see if we can erase that and just get a little bit better on it. Okay, how about 3? There we go. Okay, now it looks like it. All right, so if I use this formula and I plug these numbers in, I say 3 subtract 1 for my y's, y2, this is x2, and this is y1, and this is x1. So I plug them in, and I get 3 minus 1, and then I get 3 minus 3, which equals 0 on the denominator and 2 on the numerator. Well, wait a second. I cannot have 0 in the denominator because we cannot divide by 0. So anytime you end up with this 0 in the denominator, which is a vertical line, you're going to have what is called undefined slope. Okay? That is the basis on that information. So I really don't call it that, but it is considered a slope. Okay? But it's not necessarily linear, but it is a straight line. Now, lots of information on that. All right, let's see here. The next part is domain. The domain for this is the set of all real numbers. Because we can pick any x, as long as it's going straight, like this, it's going to continue in that direction, going to continue in this. So I can look at any x I want. Excuse me. And that is set of all real numbers. Okay? Well, guess what my range is? That's right. It is the set of all real numbers. Because now I'm looking here. And as long as it's going up, and as long as it's going down, I'm going to have the same thing. The set of all real numbers. Okay? Let's see. I think that just about covers it for what we need. If you have more questions about this, just Edmodo me. It's right at a 10-minute video. It's a little bit longer than I wanted, but it's good enough for what we need, and a lot of information in it. So if you have questions, Edmodo me, and we'll talk about it.